So in the chemical energetics, the reaction can be an endothermic, means it absorbs energy overall, or it can be an exothermic, it means that releases the energy. So there is an energy profile diagram which you have to learn for both exothermic and endothermic reactions, known as energy profile diagram or energy diagram. So for endothermic reactions, and for exothermic reactions, you should be able to complete this diagram as well as the labels. On x-axis we have the reaction progress, on y-axis we have energy. For exothermic, on x-axis we have reaction progress and y-axis we have energy. So how we complete this diagram? Number one, you will always remember that for endothermic reactions, the reactant's energy, the energy of a reactant is always less as compared to that of product. So when this is always fixed, it does not change. If the reaction is endothermic, reactant will have low energy, the product will have high energy. But if the reaction is exothermic, the reactant will have high energy and the product will have low energy. So these labels are always fixed. Reactant for endo will have low energy and the product for endo will have high energy. And opposite will happen. The reactants for exothermic reactions have high energy and the product is having low energy. That's why it releases the energy. So how the reaction proceed or how the reaction occur? So first, the reaction does not start instantly. The reactant, because it's an endothermic, so reactant absorb energy. The reactants are absorbing energy, and there will be a point where the reaction start. So the point where the reaction start and the product is formed. So the energy from the start of the reaction, from the reactant till the start of the reaction, this arrow, what it represent? It represent activation energy. I am writing in short AE. A stands for activation and E stands for energy. And there is also another arrow which you have to label, the energy from reactant to the product, that is denoted by delta H. What is the meaning of delta H? Means the change in energy, or it's also known as enthalpy change. So AE refers to activation energy. This is the energy at which the reaction starts, and the delta H is representing the energy change, or scientifically we use this term enthalpy change. So these are the terms used for the energy difference between the reactant and product. Same way for exothermic reactions, reactant will always have high energy and the product will always have a low energy. So how to label, we complete this diagram. So reactant, not instantly reactant will form a product. Reactant takes some energy very small quantity of energy. And when these reactants absorb a small quantity of energy, this is a position where the reaction start. And once the reaction start, they will form a product. So the arrow from reactant to the start of the reaction, we call that as activation energy. And the arrow from reactant to the product, that is denoted by delta H, known as enthalpy change or energy change. So this is always fixed. These are the labels which you have to memorize for endothermic and exothermic reactions. Is it clear, the concept of exothermic and endothermic reaction? Anyone having a doubt? I'll give examples how you will use this in exam to answer the question. Any doubt till this point? Okay. Now how to use the exam style questions related to the energy diagram. In exam, you might have MCQs in which they provide the reactant and product. So we have reactant and product. So they might ask, which reaction is this? Exo or endo? So using or looking at the energy profile diagram, which reaction is this? This reaction is exothermic because the reactants have high energy and the product is having low energy. That is one way they ask. So that's right, this reaction is exo. Sometimes they give you the incomplete figure of energy diagram and they ask to draw an arrow to label activation energy and energy change. The direction of the arrow is also important. So when this reaction proceeds, the reactant takes some energy to start. This is the position where the reaction start and they will form a product. So when we want to label the activation energy is from reactant to the start of the reaction. So this label is activation energy. And what about energy change? The energy change from reactant, the arrow direction of the arrow is important. From reactant to the product, the arrow will point downward. We call delta H, or we can also say energy change. So this can be the second type in which you have to complete the figure and label the arrows as for activation energy as well as energy change or enthalpy change. Is it clear till this point? Anyone having a doubt or a question? Then the second type of question, sometimes they give you the equation. The term activation energy means the energy from reactant till the start of the reaction. That energy is called activation energy. As you can see in the previous example, this is a reactant and at this point the reaction start. So when we draw an arrow from reactant till the start of the reaction, we call that as activation energy. Same thing, this is a reactant energy and this is the energy at which the reaction start. So when we draw the arrow, the term activation energy means the energy at which the reaction start. That's called activation energy. The minimum possible energy for reaction to occur. At this energy, the reaction start and the reactant will convert into product. Sometime the equation is given. CaCO3 gives CaO plus carbon dioxide. And simply they say draw energy diagram for this. And you have to label activation energy and energy change or enthalpy change. So first, before drawing this energy diagram, we have to identify what kind of reaction is this. So what kind of reaction is this? Can you say is this endo or exo? It will be an endothermic. Why? Because only one reactant and more product. So actually this is example of thermal decomposition. So this is thermal decomposition, and as we discussed in the last session, that thermal decomposition is always endothermic. Endothermic means it absorbs energy. So when we draw energy profile diagram, we have to draw energy profile diagram for endothermic. An energy profile diagram for endothermic, the reactants have a low energy, the product will have high energy. So what is the reactant here? Calcium carbonate is a reactant. And what are the product? Calcium oxide and carbon dioxide are the product. So when we complete this, the reactant absorb energy. At this point, the reaction start and they will form a product. So labeling the arrows, energy of the reactant to the start of the reaction, we call that as activation energy. And energy of the reactant to the energy of the product, we call that as enthalpy change or delta H. Is it clear? Discussion? Anyone having a doubt in this example? That completing the energy diagram for the term delta means change. This is a Greek alphabet which is called delta, used to represent the term change. So when we write delta H, it's a representation that the change in energy. So delta is means change and H is representing the energy. Then another example, if I say draw the energy profile diagram for uh, methane is there, reacted with oxygen, gives carbon dioxide plus water. The equation must be balanced. So we have 4 hydrogen here, so we put 2. So hydrogen is balanced and we have 4 oxygen, 2 plus 2. So we put 2, oxygen is also balanced. So now this equation is balanced in terms of carbon, hydrogen and oxygen. So we have to draw the energy diagram, but before drawing the energy diagram, we should identify what will be this reaction, exo or endo. So what will be the reaction? We have to draw the energy diagram for this reaction. What will be the type of reaction? Is it endo or exo? Methane reacted with oxygen. Methane burned in the presence of oxygen to give carbon dioxide and water. What will be the type of the reaction? Because it's a combustion reaction. When reaction is combustion, it is always exothermic. Burning reaction, combustion reactions are always exothermic. So in a combustion reaction, exothermic reaction, reactants have high energy and the product will have low energy. So what are the reactants? We have CH4 plus 2O2 are the reactant and CO2 plus 2H2O is a product. So when we complete, the reactant absorbs some energy to start the reaction, and once the reaction started, the product will be formed. The term exo means it releases energy, and how we identify it is exo. If you remember, I gave you example of burning and combustion. Burning and combustion always involve oxygen as a reactant. So this is an example of combustion or burning. Whenever oxygen is involved as a reactant, we can identify that this is a burning reaction, a combustion reaction. So it will always be exothermic. Energy from the reactant to the start, that's called activation energy. We can write AE. And energy from reactant to the product is called energy change, enthalpy change, or denoted by delta H. Is it clear how we can complete the energy diagram? For exothermic reaction? So first thing, you have to identify the type of reaction, and then the energy diagrams are fixed. For endothermic, reactants have less energy, product is more, whereas exothermic reactants have high and the product is having low energy. Then some examples. So exothermic reactions produce heat energy which can be used for different mechanisms. So as we know, the exothermic reactions, they release energy, and that energy can be used. Like example, we can use that energy for cooking food. That we how we cook food, we are burning methane or the natural gas, and that produces heat energy. So we can use it to cook food. Same thing in power stations. We can burn coal and oil, and that convert the water into steam and produce electricity. So we can use different types of fuels. Fuel is basically a substance which can produce energy, that is called a fuel. So whenever something is used as a fuel, the reaction will always be exothermic. So first one, like fossil fuels. Fossil fuel involve like coal, oil, gas. So when we burn this fossil fuel, like example, if a coal is there, it burned in the presence of oxygen. What it will release the heat energy. The product coal plus oxygen, coal is carbon. So carbon plus oxygen gives carbon dioxide. Same way we have like methane, the natural gas which is used as a source of energy, plus oxygen. So when we use them, it produces methane contain carbon and hydrogen. So when we burn, it produces carbon dioxide plus hydrogen, plus water, not hydrogen. It contain hydrogen, so that produce. And what will be the kind of the reaction? What will be the type of the reaction? This reaction will be exothermic. What is the kind of this reaction? Because it is used as a source of energy, the reaction will be exothermic. And what is the fuel here? Coal is a fuel, methane is a fuel. Oxygen is not the fuel. Oxygen help in the combustion of the fuel. When fuel react with oxygen, like example petrol which we use in the car, so that petrol burn in the presence of oxygen and produce energy. So petrol is the fuel. We don't say oxygen is a fuel. We say petrol is the fuel, and for combustion of the petrol we need oxygen. And this reaction, whenever we burn something in the presence of oxygen, the reaction is exothermic. And there is also another term used for these type of reaction. When oxygen is added, that type of reaction is also known as oxidation. So this is another definition of oxidation. We discussed the definition of oxidation in terms of electrons, but there is another definition of oxygen, that is the addition of oxygen. So when oxygen is added to something, what we call that reaction, we call that as oxidation. So this reaction in terms of energy, this reaction is exothermic because it is releasing energy. And in terms of involvement of the oxygen, it is also known as oxidation. Is it clear, this example? The first one, we use different substances as a fuel. So when we use fossil fuel, we burn them, it releases energy, and the reaction is termed as exothermic as well as oxidation. Any doubt till this point? Then the second type of fuel which we use hydrogen as a fuel. Hydrogen can also be used as a fuel because hydrogen can easily catch fire. And where we use this, it is used in a fuel cell, which supply power to space probes. So normally when they're sending these rockets missions to the space, there is a device which is called a fuel cell. Basically fuel cell uses hydrogen as a fuel. How it works? I'm not drawing it complete fuel cell, like it's like a box which is having two inlets and one outlet. So what happened in a fuel cell? One side hydrogen is added, the other side oxygen is added, and when this hydrogen and oxygen combine, react, the hydrogen mix with oxygen, what it result? It result in a formation of water. So hydrogen plus oxygen, the hydrogen combined with oxygen, and this result in a formation of the water, and it release energy because this oxygen is involved. As you can see, one of the reactant is oxygen, so the reaction will be exothermic, and because oxygen is added to the substance, we also call that as oxidation, because oxidation means addition of oxygen. And what is the fuel here? Which substance is used as a fuel? So this hydrogen is used as a fuel. So in a fuel cell, what happened? They mix hydrogen with oxygen, and when they mix hydrogen with oxygen, this result in production of energy, and that energy can be used to devise different mechanisms. And why it is useful here? Because it does not produce any harmful substance, it produces water as a product. So it is also useful that water will be there as a product. But what is the disadvantage here? When we are using a fossil fuel, so it produces carbon dioxide, and carbon dioxide can cause global warming. That's why it has a disadvantage when we use fossil fuel compared to the hydrogen fuel. But hydrogen fuels, because it is difficult to extract the hydrogen, take out the hydrogen, the main issue with the hydrogen is how to extract hydrogen and store hydrogen. It is a difficult thing. That's why you don't find the devices, the things even are working with hydrogen. They normally use petrol and diesel or natural gases instead of using hydrogen, because it is difficult to store. But there are hydrogen buses which are having hydrogen fuels. Normally in Germany they run this hydrogen fuel buses. The test run was there, but it's not common. Number one is availability of the hydrogen, and number two is storing the hydrogen is a difficult technique, because we need a high pressure to store a gas as compared to a liquid. It's easy to store. Is it clear? The hydrogen fuel cell, hydrogen when we use as a fuel. Anyone having a doubt or a question about hydrogen fuel cell? And the third kind of fuel, that is known as the nuclear fuel. The nuclear fuel, what we do, we use uranium. This we already discussed in physics. Energy topic, we use uranium, which is 92 and 235, the isotope. And we break down this uranium by the help of neutron. We target this uranium by the help of neutron, and this uranium nucleus break down into smaller nuclei. So lighter nuclei are produced, and the energy is also released. So what we call this reaction, when we use uranium as a fuel and we break down the heavy nucleus into lighter one, what we call? Is it nuclear fission or fusion? Which reaction is this? A heavy nucleus break down into the lighter one, so we call that as nuclear fission reaction. So when we use a nuclear fuel, we break down this uranium into a lighter fragment, and that releases energy, and that energy can be used to produce electricity. This is what happened in a nuclear power stations. And this reaction is exothermic, but this is not oxidation. Why this reaction is exothermic? Because it is releasing energy. But why it is not an oxidation? Because it does not involve oxygen as a reactant. That's why it is not an oxidation. So these are the three fuels which we use to generate electricity or as a source of energy. Like fossil fuels are there, hydrogen fuel is there, and the uranium or the nuclear fuel. The disadvantage of using a uranium fuel, because that is radioactive, it emit out harmful radiations that can cause cancer. So, and we have to keep a certain distance from the source to carry out this nuclear reaction. Now some topic wise questions we'll discuss. So the diagram shows the hydrogen fuel cell. What happened, Abdullah? In a hydrogen fuel cell, hydrogen is added to oxygen. So when hydrogen mixed with oxygen, what it formed? It formed water, and where this reaction occurred, that is called a fuel cell. So hydrogen plus oxygen produce water. The reaction is exothermic and also oxidation because it is addition of oxygen. So that is a simple way, hydrogen reacting with oxygen to give water. How it is used as a fuel? Because the hydrogen reacted with oxygen. So when what is the meaning of the fuel? The fuel means the substance which releases energy. So the substance which release energy is known as a fuel. Because when hydrogen reacting with oxygen, it form a water, and due to this chemical reaction, energy is released. So we say that hydrogen is a fuel here. That hydrogen combined with oxygen to give water. Same thing like petrol combined with oxygen to give carbon dioxide and water vapors. So we use petrol as a fuel which release heat energy, can be used to devise different mechanism. So the diagram shows some properties that substance may have. To which label does uranium belongs to? First thing, uranium is an element. We have to select the common factor. In mathematics, maybe you have studied the Venn diagram, in which you make a common factor, the common properties, by the region where the two circles intersect, that is showing a common property. So if we check option A, what is the meaning of option A? Option A is a combination of compound and used as a source of energy. So uranium is used as a source of energy, but uranium is not a compound, so it cannot be A. So it cannot be A. When we check B, B means compound and radioactive. Radioactive means emit out radiation. It is, yeah, radioactive, but it is not a compound, so B is wrong. C means all the things are there. That's totally wrong. So correct answer is D. that uranium is a source of energy and it is also a radioactive. Is it clear, this example? So because the property uranium is used as a source of energy and it is radioactive, so the common property is for D. The calculation part we'll discuss later. That's why uh, that is the next session we'll discuss. Question number 9. What could be the answer for question 9? Which statement about fuels is correct? Yeah, what about others? So when you check the option, they say heat energy can only be produced by burning fuel. It's written only. And right now we have discussed it's not necessary we burn a fuel. As the example of the uranium, as I show you the example of the uranium, in case of uranium, we are not burning. This is not a burning reaction. This is a nuclear reaction. So without a without a burning, we can also produce a heat energy. So that's why A cannot be a right answer. When we check B, hydrogen is used as a fuel. It is difficult to store. B is the right answer. As I mentioned, we can use hydrogen as a fuel. But the problem is it is difficult to store. Methane is good fuel because it produces only water. That's wrong. Because when we burn methane, it produces water and carbon dioxide. Uranium is burned in air. Uranium is not burned in air. There is a nuclear reaction, nuclear fusion, which produce heat energy from the breakdown of uranium nucleus. So it's not a burning reaction. That's why for question 19, B is the right answer. Is it clear? Question 9, B is the right answer. Is it clear? If you read statement A, heat energy only produced, that's wrong. It's not the only way produced by burning. There are different ways by which heat energy can be produced. So the next session, we will discuss more questions related to this topic, the chemical energetic. So today we discussed the definition of an exothermic and endothermic reactions and energy change, an energy diagram for a exothermic and endothermic reactions. Tomorrow we'll do calculations how we can calculate the energy change for endothermic and exothermic reactions.